I opted to put this piece of the lesson on a different day. Normally I roll this into the same day as the lesson before, but I actually like splitting it up a little bit because it is different. This is not a trinomial. This is going to be factoring a binomial, but it's like a special kind of binomial that we're gonna treat like a trinomial. So this is what's called the special case. There are a couple of special cases that we're going to talk about when you're factoring, and when we're done with all the factoring lessons, I'll give you like a map or a flow chart to kind of know when you're looking for what. But this is something called the difference of squares, and I will often abbreviate this DOS for difference of squares. Once in a while I'll do something like this. I'll do DO and then like a little square. Okay, but like difference of squares because I don't want to keep writing it up. Now, let's kind of break down what we're talking about here. Like, you know me, I'm big on vocabulary and you guys knowing what the words mean so that the language makes sense to you. So the word difference in math means to subtract. So if we wanted to know the difference in our ages, like your age compared to my age, and somebody said, what's the difference in your age? We would subtract them. Okay. It would be another way of asking how much older is Miss Taylor than her students. And that number keeps getting bigger. And then squares refers to, perfect squares. Okay, and I'll mention, like, we'll talk about what perfect squares are. But that's what we're talking about. We're talking about numbers that are perfect squares. Sometimes you'll see this written as the difference of two squares. Okay, and yeah, and two just means that there are two terms in it. So I'm going to give you some examples, and I'm actually going to work through two of the examples like a long way, because what I want you to see is that this is not something different from what we covered in the last lesson. It's the same thing, except that there's a faster way to do it because it is a special case. So first thing we want to recognize is what our perfect squares are. So your perfect square numbers are numbers that result from integers being squared. And so your perfect squares would be like 1 squared. So 1 is a perfect square. 4 is a perfect square. 9. Okay. And so like the list would go 1, 4, 9, 16, 25, 36, 49. And hopefully you know what I'm doing there. So I'm just going up and doing like 5 squared, 6 squared, 7 squared, 8 squared. The next one would be 64 and so forth. Now, also considered perfect squares would be something like x squared, because x is the result, x squared is the result of x times x, or y squared would be the result of y times y. And so when you have a variable, that would also be considered a perfect square. So what I'm going to do, and this is not something that I want you to write down so much as I want you to pay attention to. So if you're watching this in period 3 or you're watching this on your own, I don't really want you to write this down. I just want you to follow what I'm doing to try to connect these ideas a bit. First example is x squared minus 16. So what we want to notice first is that this is the difference of two squares. Difference meaning we are subtracting them. And then the two terms, to go back to another vocab word, are both perfect squares. X squared is the result of x times x, and 16 is the result of 4 times 4. So I'll kind of write that over there. We need to be able to recognize when we're looking at the difference of two squares, because otherwise you don't know what kind of problem you're looking at. Now, normally we don't add more stuff into a problem, okay? But I'm going to add something in. I'm going to take the x squared and I'm going to put in 0x and then minus 16 and let you look at it for a second, because I don't really want you writing this down. So what we did there was we put in what's called the x term, or the linear term. It's the term that has just the x. And 0 times x is 0, and so that's why you don't see it. Now, I could put it in there. I could just write it in there. It's like extra, but it's not wrong. And the reason I'm doing that is to bring it back to the last lesson where we're factoring trinomials so that the way we're reasoning is consistent. I am looking, well, we know the x squared factors into x times x. And what I want is two numbers that multiply to negative 16 and add up to 0. They multiply to negative 16 and they add up to 0. So over here, I take my 16 and I'm like, okay, well, what multiplies to give me 16? 1 times 16, 2 times 8, not 3 times anything. And then I have 4 and 4. And at that point, I've exhausted all the possibilities. So I can't get a 0 from a 1 and 16. If I add them, I get 17. If I subtract them, I get 15. Can't get a 0 from a 2 and an 8. Add them, you get 10. Subtract them, you get 6. But I can get a 0 from 4 and 4 if I subtract them. So if I have a positive 4 and a negative 4, then that would multiply to give me negative 16 and add to give me 0. And so we would have a positive 4 and a negative 4. Now what I want you to notice about this is that I have plus and minus of the square root of whatever those terms were. So like the square root of 16 is 4. You think what times itself gave me the 16. And you end up with the plus and the minus. Now that maybe just only happens this one time. So we're going to look at one more example. If I have x squared minus 49. So you want to recognize that this is the difference, subtraction, of two, so it's a binomial, squares, because x squared is x times x, and 49 is 7 times 7. So that helps us identify what we're looking at. Now, as before, I'm going to put in that weird middle term, okay? We don't usually want that there, but I want to be consistent with what we were doing last time. I need two numbers, so I'm going to put my x's here, two numbers that will multiply to give me negative 49 and add up to give me 0. And again, I'm doing that so that the way I'm talking about it is the same way as I was talking about it last class. So let's do our scratch work. What numbers multiply to give us 49? Well, 1 times 49, that is not going to give you a 0. Okay, there's no way to do that. And 7 times 7. That would give me the 0 if one of the 7s was negative. So if I had negative 7 plus 7. Negative 7 plus 7 is 0, and negative 7 times 7 is negative 41. And so we have plus 7, or minus 7 and plus 7. Now, notice again, you have the x and the x, the 7 and the 7, so you have the same thing, except one of them is minus and one of them is plus. And it happens to be the square root of 49. Now, that's not a coincidence. That will happen every single time you have the difference of two squares. Every single time. And so when we see patterns like that, we can go back to the consistent, because math is consistent. It follows the same rules. What we're doing here is the same thing that we were doing last time. But when we recognize a pattern, we can use that pattern to create a shortcut. It's just important to know that it's not magic. It's not this totally different kind of problem. So here's the general rule for factoring the difference of two squares. Not rules, there's only one of them. Is this: if you recognize that what you're looking at is the difference of two squares, difference subtract, 2 means it's a binomial, there's only two terms, and they're both perfect squares. That will always factor into a plus b and a minus b. So you would figure out what times itself gives me a, or a squared, like what is that? What times itself is going to give me b squared, like just kind of think that through. And then one of them is positive and one of them is negative all the time. And you don't have to go through like this bizarro thing where you're putting a 0 in the middle, unless you really want to, but I would not recommend doing it. Okay, now I'm going to throw out a very, very, very important vocab word. So important that I'm going to use, no, that'll never show up on the PowerPoint slide. Okay, I guess we'll just use red, okay? Very important vocab word. This just is going to keep coming up over and over and over again, and we'll put lots of exclamation points. Okay, the very important vocab word is conjugate. 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 These are called conjugates of each other, and it's like so important that I'm going to put this word again over here. Conjugates, okay? And conjugates are when you have plus and minus of the same thing, except like one has a plus sign and one has a minus sign. So like these would be conjugates. X plus 3, x minus 3. 2x minus 5 and 2x plus 5. I don't know. Let's do 3 minus 4i. You guys have no idea what that is yet, but just, you know, hang out in Algebra 2 and we'll cover it, okay? 3 minus 4i and 3 plus 4i. And we'll do x, y, z plus, I don't know, 2 and x, y, z minus 2. Okay, so you get the idea of what conjugates are. Like these are kind of simple conjugates, and then that's just a mess. But the idea is that you have the same things in the parentheses, but one of them's plus, one of them's minus. It doesn't matter what order they're in, and they're called conjugates of each other. Like they always come in pairs. So you have one and then you have the other. And what's super important about conjugates is that when you multiply them, the middle part is going to cancel out. Like that's crazy important. So if I were to look at, we'll do the simple one, the x plus 3, x minus 3. If you were to multiply this through, you get x times x is x squared. X times negative 3 is negative 3x. 3 times x is 3x. And then 3 times negative 3 is negative 9. When you look at the middle, they'll always match and they will always cancel out. So negative 3x plus 3x is 0. And you're left with x squared minus 9. So just file that vocab, like just file that away. So let's do some practice problems with factoring the difference of squares. And if this seems easy, just hold tight. We will eventually put all of our factoring together. We're going to do the GCF and the factoring trinomials and the difference of squares. And we haven't even touched when the leading coefficient is not 1. Although one of these today does not have a leading coefficient. It's a challenge problem. So I want you to factor x squared minus 36. I want you to factor x squared minus 1. And then I want you to factor 4x squared minus 25. Now, this one is more challenging, and I broke the mold. So this one does not look like the other ones in the lesson, and I'm totally aware of that. But go back to what I said here about, like, you're going to figure out what times itself gives you whatever you're looking at. So you're going to think, what times itself gives me 4? What times itself gives me x squared? What times itself gives me 25? And then see if you can figure it out. And for those that are watching at home, okay, here are the answers so you can check your work. The answers to the first one would be x plus 6 and x minus 6. And if you wrote x minus 6, x plus 6, that's fine. I usually do the positive first. Next one is x plus 1 and x minus 1. And then the third one is 2x plus 5 and 2x minus 5. And again, the order of the plus and minus doesn't matter. I just always do the positive first. Like, that's just what I do, but there's nothing magical about that. So if you're like a negative kind of person and you want to get the negative out of the way first, I don't care. All right. And so that's a wrap on that. Next lesson, we're going to do a review, and then we're going to talk about slide and divide.